Hello, everyone, and welcome to the Cutting Room presentation brought to you by the Equipment Division of IFAI. My name is Christine Girard, Division Supervisor for the Equipment Division, and I will be moderating the webinar today. Before we get started, I'd like to go over a few items so you know how to participate in today's webinar. You will have the opportunity to submit questions to our presenters by typing them into the questions box of the control panel. You may send in your questions at any time during this presentation. I will collect them and they will be addressed during the Q&A portion at the end of the presentation. A PDF of this presentation is currently available for download under the Handouts tab of your control panel. A link to download it will also be emailed to you later in the week. We're going to begin with 3 poll questions to help our presenters understand the audience better. Please answer the poll question now, located on the control panel under the polls. The first question is, what industry are you in? Please select Other if your industry is not listed. We're going to give everyone a few moments before we launch the second poll. The second poll question is, do you currently use CAD software? Yes or no? And finally, the third question is, how are you currently cutting? Automated cutting or manual cutting? All right, thanks everyone for taking a moment to answer the poll. I would now like to introduce today's presenters. Our first presenter is Tri Pham, the Director of Global Sales at Automatrix Precision Cutting, manufacturers of cutting equipment and CAD software. Our second speaker is Trevor Stevenson, Vice President of Eastman Machine Company, a family-owned and operated automated cutting business since 1888. We will now begin the webinar. Please welcome Tri and Trevor.
Thank you, Christine. Good morning, everyone. This is Tri with Automatrix. Today, I wanted to cover some of the basics of what you need to know when you begin to explore converting to digital patterns of your IFAI products, and when you consider the investment of an automated cutting machine. There are 4 modules today. I will speak on some basics of software and the actual automated cutting machines themselves. Trevor will do the next 2, and he'll speak on material handling as it pertains to the cutting room. And then he'll end with how we equipment manufacturers like to help you crunch numbers to justify the investment. Patterns and some software can be very industry specific. Awning manufacturers use certain attachment details like a rafter band that a tent manufacturer would never consider, or an inflatable manufacturer uses certain material functions that a marine canvas shop doesn't need. So we don't have the time to talk about each industry individually, but more importantly, every cutting room is different. But I hope that this time today will give you a base to invoke questioning and give you a vision path on how software and equipment can help in your cutting room. So I'll start with software first. Trevor at Eastman will be very familiar with this interaction. We exhibit at a lot of trade shows. So let's say we're at IFAI Expo, and a fabricator walks up to one of our booths and looks at the cutting machine and starts asking questions such as, can it cut this fabric? Or what is the top speed of this machine? Or what kind of blades do you use? Those are all important questions in finding the right solution. And although cutting machines, it's the meat of the investment, and that's what's driving your return, the more meaningful conversation to start at is how you guys are patterning and designing your products. In a standard shop that hasn't automated, it's a labor-intensive manual process. And the more complex the pattern, the more time it will take, and the more likely it is that an error will be made. And when it comes to patterns within IFAI, Eastman and Autometrics, we've seen them all. We have the tarp manufacturer that needs to pull the whole roll of fabric, cut to length, and it could be as simple as a rectangle. We've seen the retractable awning manufacturer that needs to cut the same trapezoid over and over, but just in different sizes. And then there are the very dynamic patterns that will eventually turn into, let's say, an inflatable, or a piece of furniture, or a piece of apparel. And then to add another layer of complexity, we have our friends in the awning, marine, and many other industries in IFAI that serve a very custom client base. So in order to talk about how we can improve in the cutting room, we have to consider how you're making patterns now and the best way to transition from there. So I've seen many customers not make patterns at all. So every piece of manufacturing is on the fly. This is typical of a very experienced cutter that have all the nuances and knowledge and memory because they've been doing it for 30 years. Second, in a more detailed fashion, many fabricators in different IFAI markets will have a library of paper or plastic templates. And these templates are created by draping paper or plastic over what you're needing to cover, then taking that template, tracing it over fabric, including all the grommets, all the marks for sew lines or darts, and then taking a pair of scissors to cut out that fabric. And after all that's done, you keep the template in the case you ever run across that job again. So after years of being in business, your cutting room will eventually consist of rolls of material, your cutting table, and a wall full of templates. And a lot of people get to this point. And then in the event of a recover, taking that old cover, using that as a template. Or using that as a template or pattern. This is common in upholstery. Let me get there. So that leads us to digital patterns. To segue from the last slide in the shop that has the wall full of templates. Digitizing software and hardware is the tool that will improve many parts of your cutting room. Digitizing can be found in many forms. There are string measuring equipment, there are plotting tools, there are photo digitizing tools that use nice DSLR cameras. Our smartphones are even powerful enough these days to digitize your patterns. The basics of digitizing are to take an existing template and turn it into a digital pattern ready to be cut on an automated machine. Second, there are endless options for CAD software capable of designing products in IFAI. Most of you have heard of AutoCAD or RhinoCAD or SolidWorks. That's what I'm talking about here. CAD stands for Computer Aided Design. Many of you are using some form of CAD currently from what I saw from the polls. How the cutting machine companies in IFAI can help here is determine if there is a dedicated software for your industry or product. And if your product is extremely unique or AutoCAD is your only option, we can help with the best way to integrate our software running the cutting table to the software that you're using to make your current patterns. And then the last method that I wanted to point out is using equipment that uses distance to the device to measure in a 3D space. So the photo on the top right of this page is of a string measuring device. There's also a laser variant as well. How these devices work are that they sit on the ground or on a tripod. Most importantly, it's stationary. There's a software that runs the equipment, but you use the device to plot points. And as you plot points, it takes the distance, it takes the angles, and creates a three-dimensional cloud in which you use a software like AutoCAD or RhinoCAD to connect all the dots, and then you create a surface, which is the beginnings of a pattern. So after you create your pattern in a digital form, and before you send it to an automated cutting machine, there's a process called nesting. And this can be done manually, typically if your patterns are very simple, but to see the best results, software will help you automatically nest all your patterns in the quantities you instruct. So let's say you're making duffel bags and you have an order for 100 of them. Auto nesting works within the software that runs the cutting table. It grabs all the panels required to make a duffel bag. It could be 3, it could be 10. It multiplies it by how many duffel bags you need to make. In this case, it would be 100. And then it places it on the virtual view of your cutting table to best use the material that you're paying so much for. An example of that, and this is not duffel bags, but an example of that is the screenshot of Eastman software on the left-hand side there. Nesting software also takes into account the width of your fabric, the length of your table, the amount of patterns you told it to nest, and there are even camera systems and hardware to nest on unique shaped materials such as leather, and that's the other screenshot on this slide. So now, what do you do with your patterns? You have to cut them out somehow to get them ready for sewing or heat sealing. And again, all the methods fabricators can currently use to cut fabric. Everyone has traditional scissors. Everyone started with that method, right? An OFA style tool is a rolling blade inside of a holder, very similar to a box knife. There are spinning blades made to get through tough material, and even oscillating cutters to get through stacks of material. And finally, there are a few variations of die cutting as well. Mainly what we wanted to discuss with you in this equipment module is automated cutting. In other terms, some people call it a plotter, some people call it a cutting table, a cutting machine. This is all referring to the cutting machines you see within IFAI cutting your unique pattern. It's an automated gantry driven by software that manages your pattern. The material is held in place on a vacuum table while the gantry cuts the patterns so that you don't have to. Cutting machines are made of two main parts. There's the moving gantry, and the motions are described in axes. X-axis is the width of your fabric. The Y-axis is the length of the table. And theta axis is extremely important. That's the direction in which the blade is traveling. More so, it's how the blade steers as it's going around your pattern. And then the second main part, self-explanatory, of the cutting machine is the vacuum table, which supports the fabric you're using. So diving into the gantry, which is the most visible part of the machine since it's constantly moving to cut your fabric. The gantry can be described in two major parts, the drive system and the cutting head. And the most important part of the gantry is the active cutting head. It carries the blades, it steers them to cut whatever pattern is sent to the machine. Most machines use pneumatic actuated tools to engage and disengage the cutting. The cutting machine is driven by motors with either rack and pinion or some sort of belt drive. Ultimately, the machine is only as accurate as the parts it's made of and how accurate the drive system is. You know, the motors can be stepper or servo motors, but either way, if the motor says that it moved X distance, but the pinion or the belt on the drive system determines how accurate that move ended up being. And then also keep in mind that any flex in the system also translates into loss of accuracy. So this is a little bit more technical of a conversation instead of it being an application discussion. But I'm giving you this information for you to be critical of as equipment manufacturers. So when you're shopping around for equipment, check their tolerances, ask detailed questions about how the equipment holds up over time. ask about common spare parts, and of course, ask for a reference to make sure the ownership experience lives up to our manufacturer's claims. So back to the cutting head. The cutting head can carry many different kinds of blades to take care of the details that you need in your pattern. Cutting tools that you will see in IFAI or round rolling blades and drag blades. These blades come in many different sizes and are made of many different variations of metals. Consult with Autometrics, Eastman, or any other IFAI cutting equipment company to make sure that we match the right blade for your material and the complexity of your pattern. The other tools that can be on a cutting head are punches, notch tools for sewing alignment, pen holders that can hold chalk pencils, space pens, ballpoint pens, Sharpies, and then even printing tools for marking, such as dot markers and inkjets. The pen tool and inkjets are very useful to most fabricators using cutting equipment. This can be used to print a job number, a part number, a barcode to integrate with your production software, or some details that may be important for your sewer or your heat welder as they're fabricating the product. So next, cutting tables are generally categorized by two types. Static cutting tables have the parts that we described, which is a moving gantry and a vacuum table. The vacuum table was built to a width and length that suits your fabric rolls and production needs. And here are a couple photos of static systems. You'll find that the width of cutting tables cater to the typical material width that you'll find in the market. So purposefully, we built tables that are made to handle 60, 70, 80, 96, 104, 119, and so on, wide materials. And the length of static tables are virtually limitless. But a common size in IFAI is a table in the length of that 20 to 40 feet. A rule of thumb that we use to help customers find the right length table, 80% of your patterns are within this length. Of course, we know fabricators in IFAI take on custom work every day. So you may never find the perfect length of the static table, but we try to help marry any restrictions in floor space with your production volume, your pattern size, and of course, respecting and working within your budget to find the right width and length configuration machine. Conveyor tables are the other category of automated cutting machines. They use a similar gantry as the static table, but the vacuum table is a driven belt. There are quite a few positives in this type of system. If you can imagine loading a roll of material and then within the software, auto-nest 20 tables worth of patterns. Hit start and watch this thing run. So all your operator has to do at that point is stand there and pick off cut parts. The intent behind the conveyor table design is for high volume throughput, but this also draws clients that have restricted floor space. Conveyor tables are engineered to accurately cut patterns that may be larger than the length of the table as well. So you're getting fully automated material cutting and takeoff in a smaller footprint. And then lastly, for my two modules and to finish up software and machines, I wanted to give you this list of benefits to marinate on. Some of you will find that only one of these will be a major factor in your decision to automate. Some of you can relate to the entire list. Time savings is an obvious one. Software and equipment helps you lay out your templates faster. It certainly cuts faster if you have yet to automate. And being conservative, the number I like to provide to customers is that 1 hour of automated cutting is equal to 8 hours of hand cutting. And again, that's a very conservative number for us equipment guys. Material savings is the other major component of ROI. Most companies report a savings of 10 to 40%. This is a direct result of nesting your patterns within the software. It's also a function of increased accuracy. It reminds me, I was told by a customer once that their material supplier thought they were buying from someone else, but in actuality, they were just scrapping that much less material in their first year with automated cutting and software. Next is increasing accuracy. Increasing accuracy and error elimination go hand in hand. When you automate, you don't have to rely on your employee using old patterns or laying out the template by hand and then cutting it correctly. There are plenty of potential problems with this manual model. Poorly cut pieces have a direct impact on the quality of your end product. Also, sewers aren't happy with pieces that don't fit together, and cutting them is a lengthy process. And of course, all this ties back to material efficiency. Organization is very important. Generally speaking, about patterns here, it's much easier to find the patterns you need when you have a folder system on a computer. It's much easier to make modifications to them and to save custom jobs for later use as well. And now that you have digital patterns, no space is used. You can back them up so they don't go missing and they don't ever get damaged by months or years of use. And for you fabricators, it's extremely important for you to have an easy way to make digital patterns. Pattern creation should not be intimidating, but it can be a major hurdle if it's too hard to create a pattern where you're not using the optimal software. So consult with Trevor, myself, any other cutting company will make sure the best way to transition to a clean, easy to use software and machine solution. So that wraps up my 2 modules for software and machines. We're going to hand the controls over to Trevor. Thank you for your time today. But for our next 2 modules, please welcome Trevor Stevenson with Eastman Machine Company.
Thank you, Tree. I appreciate that, and thank you for the informative presentation that you just gave. I will be covering material handling, feeding, and spreading, and also look at a quick calculation on return on investment for a typical machine. The first slide, or the first section, is on material handling. And there's 3 separate components to material handling. And material handling, feeding, and spreading can be used whether you're cutting manually or automated. Feeding systems are primarily used to feed a conveyor or a static system. So a feeding system is usually for an automated customer, and it is an efficient way of introducing roll fabrics to a cutting table. It comes with a lot of options that I will explain in a little bit. Spreading systems can be used for automated companies looking for a stack height for a multiply machine, or they might be using a manual machine. But it is an efficient way to stack material with correct edge alignment on a spreading table. They are good for short runs where production is limited, or for complete front-end preparation and large spreads. Material handling systems come in simple roll stands all the way up to data-driven carousels that collect rolls and can be part of your ERP system and inventory control. So let's look at feeding systems in a more detailed manner. These are the systems that would feed a machine. They're all sizes and different roll weights. The biggest I have seen is over 160 inches wide. They do come with optional edge controls for ply alignment so that your material is getting fed properly and online with your cutting system, so that when you're cutting, you don't want your cuts off or coming off the material. It's suitable for many different materials, and it always has a relaxed, tensionless feeding using a dancer bar. So the material goes over a feed roller under a dancer bar, which comes up as the material is spread, activates the motor, and then more material is rotated through. On this slide, I wanted to show a roll stand blown up. So these can be 1 roll, 2 roll, 3 roll, up to 6 rolls we have seen in the marketplace. Again, this is the machine where the material goes over that drive roller on top and then under the dancer bar, which is kind of a mechanical mechanism to tell the machine how far to go. Spreading systems. Spreading systems can be as simple as the bottom right picture there, which is a manual spreader where you put the roll on, you feed it through a couple guides, and then a operator walks it up and down a spreading table. It's very efficient. It's for lightweight materials, but again, you're using a laborer to move it up and down the table. And then the other side of that, the extreme side of that, is the top left, which is an automated spreader. Usually comes in a cradle design, and these things can hold up to 2,200 pounds and come in various widths. The automated one on the top left can have speeds up to 110 yards per minute. Many in the industry have a cutoff knife for flaws or for face-up spreading. They can also have turntables and other options such as barcode scanners, flaw removals, Wi-Fi capabilities, machine diagnostics and maintenance prompts, step layer capabilities, file management, and also management reporting. So there's three types of spreading, and it's all dependent on the material that you're cutting. You have face-up spreading, which is each layer is laid face up with the grain or pattern running in the same direction. A knife box is always required for this because the spreader will go down the table, cut off the spread, go back to the original position, and spread again. It is the least efficient way to spread because you're not spreading on both ways in both directions. Face-to-face spreading is the most efficient spreading because as the spreader is moving, it is always spreading material. That is good when the material does not have a pattern or a nap, such as, say, corduroy. It is a more consistent material. You might see it in denim or even sunbrella, Kevlar. So consistent materials that have the same properties on front and back is used for face-to-face spreading. There's also face-to-face nap one-way spreading, and that is also knife boxes required. That is, fabric is spread so that the nap sides face each other. So for the example, on the corduroy, it would be spread face-to-face so that the corduroy is facing each other. And it's good when you're cutting, say, a pair of pants that you have the exact opposite, so they're symmetrical. Material handling systems can go as simple as the bottom right, which is just a simple roll rack. They keep materials off the floor. They do improve safety, and you don't have rolls laying on the ground getting dirty, people tripping over them. They also can be used for a feeding system as well. However, they don't have, or normally do not have, edge control or any tension-free spreading. The one on the left is a carousel, which is semi-automated in terms of being able to rotate through the rolls by a push of a button, and they can also store data. The most complex ones you see out there are can actually count the amount of material you pull off each roll and store that in a database to talk to your ERP system. So if you're thinking about automating or getting a material feeding device or a spreading and feeding device, you want to look at your return on investment. So obviously businesses are in the business to make money, but what do you look at when you look at an automated machine? How do you determine your return on investment? There's labor savings, there are efficiency gains, and there's material savings. So with automated, it's fairly easy to see what your payback is going to be on your machine. Here's a simple calculation that I drew up. Please note that the pricing on here for the cost of the machine is hypothetical and not an actual example of a machine price from either Tree or myself. So let's look at the first column. Let's say someone is currently manually cutting / spreading. They pay with fringe benefits laborers $40,000 a year, and they're using 3. So that's a total of $120,000. They have maintenance costs on some of their manual machines of $1,500 a year, and buy $5,000 worth of parts and consumables. They cut 50,000 parts per year in this method, and they have a yearly material cost of $300,000. That gives a total cost of $426,500. Then they buy an automated machine where they only need one operator, and they use one of the same operators, so the same salary of $40,000. Maintenance costs are a little higher at $2,500, and parts and consumables are a little higher at $7,500. However, they can produce double the amount of parts they were producing before at $100,000. Material costs, due to the digitizing of their patterns and nesting software that Tree spoke about, saves them 10% on the material, giving a total cost of $270,000 for material. That gives a total yearly cost of $320,000. Using a straight line depreciation and a salvage value of $10,000 on the machine over 10 years gives a savings per year of $95,500. And if you can see in the green, all those numbers look like it's a pretty good investment. Yeah, $835,000 savings for the total life of the machine, a return on investment of 696%, a very quick payback period of 1.26 years, and a net present value of $503,139. This is an example. It is somewhat rare and maybe extreme, but it is an example of a customer that went from manual cutting to automated cutting. When they were manually cutting, they used 10 employees at $20 an hour, who worked $2,000 a year or 2,000 hours a year for a total of $400,000 total in labor cost. They bought an automated machine, used 2 employees, same hourly rate, same amount of hours per year, and only $80,000 per year in labor costs, obviously, for a savings of $320,000. So they basically paid for the machine in half a year. Rare, but doable. And that is all I have, and on material feeding and spreading and return on investment. And I appreciate everybody that joined the call today.
Thank you, Trevor and Tree. We don't currently have any questions, so if people want to put a question into the question box now, we can answer those for you. We still have quite a bit of time. So IFAI does have a question. When you're purchasing equipment, what sort of training does the equipment supplier provide? Should we start with Trevor?
I'm sorry, there are a few questions in here that I'm looking at.
I see we do have some questions. Do the feeding systems work with fabric with high stretch rates?
They do. So there's options that you can put on a feeding device, such as one example is a loop sensor. So you put a loop in the material as it comes off the roll so that it kind of goes down and makes a loop towards the floor. And then you have a sensor looking at that loop. And once that loop goes away from the sensor, meaning it's being drawn up as it feeds the machine, it feeds more material out. Using a system such as a cradle design where it's belt driven and not pulled from the roll also helps.
All right, thank you, Trevor. It looks like we did have a couple of other questions that were already answered. One just came in from Tyson. How often do you have to replace the cutting table surface on a conveyor table? Tree, do you want to go first?
Yeah, sorry, I was on mute. Yeah, it's obviously totally dependent on how often you run the machine versus 2 hours a day versus 3 complete shifts. We do have customers that would replace a conveyor cutting table in a matter of a year and a half, and then some of them can potentially go to 6 and 7 years without having to replace their table surface. I know that's a very non-committal answer, but Trevor, would you have to say the same thing? It's all based on usage, correct?
Completely agree. We have customers that have table surfaces out there for 10 plus years. Obviously, they're extremely careful with their blade exposure and pressures. And then we have customers that, yes, probably go through, running 2 shifts. They might go through it in a year because they're cutting very tough, say, fiberglass material where they're really pounding the belt.
Yes, sir.
All right, well, thank you. It doesn't look like we have any other questions. If you want to type one in, you can still do that right now.
And Christine, I'll take your question that came from IFAI about what the typical training and onboarding is to automate with software and equipment. And I would imagine Eastman would do the same thing. Whenever an order is taken, we try to get software to the customer and trained and start creating patterns as soon as possible. So that can even happen while their machine is being built. So real life making patterns that are going to be cut on their table whenever they receive it. So whenever the table is finished being built, ship it to the customer, and then a company technician goes out to install the machine. And during that installation, they would install it, they would retrain on software, and then obviously train on equipment functions as well. So that would be on operation, that would be on maintenance, and that whole training cycle on site typically is about a week. And then, of course, there's always support that we provide to the customer as well, and Eastman does the same after the machine purchase, simply to support the software and equipment function.
Okay, Trevor, did you want to add to that?
Yeah, absolutely. Tree is correct. I mean, you do not want to have a machine installed, ready to go, everybody excited for it to cut, and then not have any patterns to cut. So yes, definitely doing the digitizing and patterning of your cut files way before the machine is installed is always the right way to go. And like Tree said, most companies will always provide continuous training and support.
Okay, great. Thank you, Trevor. We do have another question that came in. Does it make sense to get a machine for a 1 to 3 man shop? Why don't we start with Trevor this time?
1 to 3 man shop, absolutely. If the production is in demand of it. If your part that you're cutting per year are so high that the guys are so busy and can't keep up, I think an automated machine is absolutely the right choice. If they're only cutting by hand, maybe, few hours a day, maybe an automated machine is not the right way to go unless you want these people to do something else in the shop. Obviously, having an automated machine frees up a lot of time and can be quite a bit faster.
Great, thank you, Trevor. We do have a question on cost. I'm going to just forward that to the speakers after the session. The next question would be, would you be able to come out and look at our operation? Okay, that's from Gary. From the recommended what equipment we need. So that they're wondering, do you ever go to people's shops?
Absolutely.
Yeah. First?
Yeah. Both of our companies will absolutely do that. Our salespeople are trained to do that, and as a sales call, it truly is a consultation. So we'll work, within your limits of budget and floor space. And of course, we'll help out to make sure we integrate the right software and the right model machine. So we will absolutely do that, and Eastman will be happy to do the same, I'm sure.
Yes, absolutely. Yeah, it's part of probably every salesperson in this industry's job function.
All right, great. Are there any other questions? All right, it doesn't look like we have any more questions. Of course, you can, forward us any questions and we'll send those off to the speakers if you have questions after today. Just as a reminder, a PDF of today's content will be emailed to you. And I just want to thank Tree and Trevor and everyone who attended today's webinar on the cutting room. Thank you.
Thank you, everyone.
Thank you, Christine. Thank you, everybody, that attended.